In this video we'll show you how we can create the 4-axis wire EDM program from the imported DXF files. So I've started the CAD system, so I'll open a DXF drawing and we'll choose this one. Okay, so that's the drawing, which is the base, and now we'll open the next drawing. So we go File, Import a drawing, and we'll use the next one. Okay, so now what we need to do is combine those two drawings. So we're going to do this using just select, copy and paste. But before I do that, what I'll need to do is, because when the two files are brought together, I'll need to specify a datum point for each one of those shapes. What I'll do is I'll add a point at the center there, so that when I select this and paste it onto the other drawing, then I'll be able to set a separate datum point there. So now we just use select, drag a window around that area and say copy. Now we go to window and open up the first drawing, which is there. Now we can just zoom out and pan and say paste, and it doesn't matter where I put this. Okay, so now when I redraw, so what I've got there is the two shapes. This one is the base, which is the XY contour, and this is the one which is 10 millimeters above, which is the UV contour. So now we need to create the contours for those parts. So the first thing is that when we're selecting a start point for each one of these entities here, then the start point needs to be sensibly placed relative to each one of the two contours. So it's difficult to see at the moment whereabouts would be a good starting point to be. So if we use the view function and say show near points, what this does is it shows all the individual endpoints of the elements. So if I now just pan and zoom into, say, this one here, so now when I create a contour, my datum point at the moment is here, and I will select a contour, and this will be my start point, and this will be the direction. So I could choose either one of these, but I need to choose a similar point on the other shape. So we click here, and that will create a contour for us. Okay, so that's there. So this contour has this set as its datum point. Now if we zoom out and zoom back in, now I create another contour, but this time I will set my datum point, and that's the reason why I created that point on the before I did the copy and paste, so that I could set my datum to there. So now I zoom in on this shape and we create a contour. So this looks like the similar position as we chose for the other contour. Okay, so we've got two contours there, each with their own datum point, but when we go into the wire EDM system, and this also applies to the milling PartMaster 2D system, is that the two datum points will become coincident. So we can now go File, Save As, and I'll call this AM both. And then we go into the machining software, wire EDM. Okay, so that's the two contours. Now you see what's happened to them. The datum points have been aligned, and these are the two contours that we have there. So what happens is when we start the Wire EDM software, it will create a simple 2-axis program for each one of those contours. Now in the normal course of events that's okay, but here we don't want that. So in the program ops window here, I'll just delete out the second one, so we're left with the first one. So now we double click that to change it. So we don't want a single contour, we want a double contour. So we now need to choose which one is which. So this is the XY contour and this is the UV contour. We give it a distance between the two contours, and then we give it the offset, which if we're cutting internally here will be to the right. So that's pretty much all we need to do. There is one other thing that we should do, which is set where we're going to have a pilot hole position. So if we go into the options tab here, we need to specify a pilot hole a distance away from the start points. And the reason for that is if you don't do that, what happens is the wire will travel at feed rate from the datum point, which is XY0, to the start point on the contour, which is really not what you want. So by setting a pilot hole position here, you can create a rapid movement between the datum position and the first contour. So if I click OK, so this is my datum position here, and you can see these are the two start points there. So if we run the animation, this is the wire moving between those two shapes. Now in this case the pilot hole position I've set as 5mm, but you can adjust this to a known position. Note also that the wire of the start hole position, the pilot hole position, will need to be somewhere where it can be addressed vertically. Okay, because otherwise how are you going to drill it? I suppose you could drill it on an angle. That's one way of doing it. So if we just post-process this, I'll use a standard FANUC post-processor. Okay, so what we get here is we get a few beginning statements here. G92 sets up the datum position, then we get a rapid movement to the first pilot hole position, then the machine stops where we can thread the wire. If the machine has an automatic wire threader, then that can be specified here. Then these are the commands X, Y, U, V. And when it gets to the end of the program, it goes back to the pilot hole position and then stops. You cut the wire and then it proceeds back to the datum point. So you would need to do that for each one of those contours, each one of those cavities, but the effect would be that within the program will start at the datum, rapid to the first contour, cut, and then proceed to the next position, thread the wire, cut round, stop, cut the wire, rapid across to the next position, and so on and so on. If we want to run the simulator on that, we can do. Use the 4-axis wire EDM, which is a general purpose simulator for all types of 2 and 4-axis wire EDM machines. We can leave all the defaults as they are. Okay, so that's a piece of material which is large enough to take in the extents of the machining. If we go to the machine tab over here, we can identify the lower spindle or the upper spindle, and if we right click that, we can hide that or make it transparent. So if we hide that and then run the so this is the rapid motion. And then back to there. But if there's multiple cavities, then it proceeds from each cavity before it goes back to the datum position. Okay, so that's how that works. I've got my stock set to transparent, but if you set it to solid, you can see the path there, but sometimes it's good to be able to see what's within those cavities. So on the bottom tab here, if you go to measure and then choose from the drop down menu remove chips, and then use the mouse wheel and depress the mouse wheel, then it finds the select chips, and then you can get rid of the material there so that you can see the actual cavity. Okay, so that's how that works. So you just need to do the same thing on the other cavities.